Hi, this video is on solving trig equations. So I'm just going to go straight into examples just to show you how these work. So with first one we've got solve 2 cos theta minus 1 equals 0, where our domain is between 0 and 2 pi. And here we can just do some rearranging. So from here we can then say that 2 cos theta would equal 1. Cos theta would equal a half, so divide the 2. Now when cos theta equals a half, the domain is from between 0 and 2 pi, so we did actually do this in the last video. So from our exact values, we know that the angle where cos theta equals a half is at pi on 3. So theta will equal pi on 3. The half is positive, which means we want the first and the fourth quadrant, which means in the fourth quadrant it would be at 5 pi on 3. B, solve minus 2 cos squared theta minus sine x plus 1 equals 0. So with a lot of these questions, you just have to manipulate often the question to put it in a form that's going to work for you. And you'll see how that really will work with this question. So if we think back to this formula, we can rearrange this so that cos squared theta equals 1 minus sine squared theta. So we can substitute our cos squared theta with that. So minus negative 2 multiplied by 1 minus sine squared x minus sine x plus 1 equals 0. Expand our brackets here, so we'll have minus 2 plus 2 sine squared x minus sine x plus 1 equals 0. And so that will simplify down again to 2 sine squared x minus sine x minus 1 equals 0. Now once we get to this part here, what you actually should notice is that it is a quadratic. And what I like to do in these situations is we're just then going to say that let sine of x give it equal another variable. We can't really use x because we already have it there, so just pick something random. I'm just going to use y. So then we can rewrite this equation. So we'll have 2y squared minus y minus 1 equals 0. Now this is a quadratic that we look like we can solve. And when you factorize this, which you can do, you'll get 2y plus 1 multiplied by y minus 1. So then from here, 2y plus 1 equals 0, or y minus 1 equals 0. Y would equal negative a half for this side, and then y would equal 1 on that one, and then we can just put our sine x back in. So we want when sine x equals negative a half, and we want when sine x equals 1. Now when sine x equals a negative half is at pi on 6, but as it's negative we want in the third and fourth quadrants, so it would be at 7 pi on 6 and at 11 pi on 6. When sine x equals 1, so that's when our y coordinates is 1, which would be at pi on 2. Now that is between 0 and 2 pi, but our domain in our question is from between 0 and 4 pi. So we just need to add 2 pi to each of these to get the other solutions. So therefore, we would have x could be pi on 2, 7 pi on 6, and 11 pi on 6, and then add 2 pi to all of those, so we'll get a 5 pi on 2, a 19 pi on 6, and a 23 pi on 6. And they're all our options between 0 and 4 pi. Part C, we want to solve 2x equals root 2 on 2 between 0 and 2 pi. So if we think back to our triangle here, the one we have root 2 is our 45-degree angle, or our pi on 4 triangle. Now root 2 on 2 remember is the same as 1 on root 2. So we have sine 2x equals root 2 on 2. Now because our domain here in our original is between, our x is between 0 and 2 pi, because we have a 2x, our domain will actually need to be between 0 and 4 pi. Because we multiply the x by 2, so we can multiply our domain by 2. So when we work out our sine of 2x equals root 2 on 2, using our exact values, we know that the 2x will equal pi on 4. Now, sine is positive in the first and second quadrant. So in the first quadrant it's pi on 4, in the second quadrant it's 3 pi on 4. Now we've got to look at between 0 and 4 pi because we have 2x. So we need to add 2 pi to each of these values. So we have 9 pi on 4 and 11 pi on 4 to get it between the domain of 0 and 4 pi. Now to put it back to just a single x, obviously here we have 2x, so we have to divide all of these by 2. So we'll have pi on 8, 3 pi on 8, 9 pi on 8, and 11 pi on 8. And that will put it back into the domain of between 0 and 2 pi. And that's solving trig equations.